Let's now solve this system of equations using substitution. Do not forget, when using substitution, you want to choose an equation and choose a variable in that equation to solve for. My suggestion is if you have a variable whose coefficient is 1 or -1, you go with that variable because then you won't go ahead and introduce fractions when solving for that variable. All right, notice this equation has x with a coefficient of 1, so I'm going to choose the second equation and I'm going to solve for x. If I take this second equation and solve for x, I'll have x is equal to -1 minus 3y. Now, I'll take my expression for x and I'll substitute it into the other equation. Very, very important. I'm now going to write down the other equation, but instead of x, I'll write down what x is according to what I just did. So I'll have 3 times, instead of x, I'll write -1 minus 3y, then continue, minus 2y is equal to -14. And notice what we have. We have an equation in a single variable, that variable being y. Let's solve for y. We'll use the distributive property, that's -3, and then 3 times -3y, that's minus 9y, minus 2y is equal to -14. We have a few like terms here. I have -3 minus 11y is equal to -14. Let's add 3 to both sides. I'll have -11y is equal to -14 plus 3 is -11. And then divide both sides by -11. And we'll have that y is 1. So can you see we have a y value, or we have the y value of the ordered pair solution of this system. Y is 1. Let me erase my work then up to a certain point. And let's remember that y is 1. So we do have an ordered pair solution, and the y value is 1. How do I find the corresponding x value? I let y be 1 here, or here, or here. This ordered pair solution must satisfy any equation of the system, so we should be able to use any equation of the system, whatever is convenient. I'll let y be 1 here, and I'll have x is equal to -1 minus 3 times y is 1. Or I'll have x is equal to -1 minus 3 times 1 is 3, or I'll have x is equal to -4. When y is 1, x is -4, and now I have my ordered pair solution of my system. These two equations, if graphed, form 2 intersecting lines. They intersect at this exact point. There's my solution.